Question 6 is coming from circular measure. The diagram shows a motif formed by the major arc AB of a circle with radius R and center O, and the minor arc AOB of a circle also with radius R but with center C. So the point C lies on the circle with center O. Part A. Given that angle ACB is equal to K pi radians, state the value of the fraction K. Now, by looking at what we are having here, if I connect this C here to B, and I also connect O here to B, now since C here is a center, and this is an arc here, AOB, this is its radius. That means even this one is R. And since O is a center, then to B here, even this one is also R. So this simply implies that OACB is a rhombus. Okay, so I can actually make these ones dotted here so that it doesn't interfere. I just make it dotted just like the others were made. Okay, so this one is R and this one is also R. Now, do you remember in your O level, you had in circle theorems that angle at the center, okay, is twice angle at the circumference. So if this was X, then this one is, they could also say it is 2X. You remember? Okay, now look at this one here. They said angle ACB is K pi radians. ACB, this one here is K pi radians. By the way, this OABC is a rhombus. So meaning this angle here, even this one, they are equal. The opposite angles are equal. Even this and this are equal. So I would actually say one of the things that I will write here are OACB is a rhombus, because all sides are equal, is a rhombus whose opposite angles are equal. Okay, now back to this property here, that angle at the center. I already messed this one up, pardon me. Angle at the center is twice angle at the circumference. So if this one was X, then this is the 2X, right? Now, this angle which is here, I want you to see what is happening here. If I marked this one with this kind of mark, then angle at the center is also like that. That means if I have something like this here, okay, this one, then the other angle also has to resemble it. So it has to be this one here. You see that? So meaning we shall have this angle here being equal to 2K pi. You multiply this by 2. Okay, so I will say angle at the center, is equal to twice angle at the circumference, angle at the circumference of the circle. That angle is subtended by the same arc. Okay, so that is why this one is 2K pi. But angles at a point sum up to 360 degrees. So this one here plus this one will give us 2 pi. So we shall have 2K pi, then plus K pi, then this one will be equal to 2 pi. What am I using? Angles at the center, angles at the point sum up to 360 degrees, or 2 pi in radians. Now, this one automatically will give us 3K pi. 3K pi, which is equal to 2 pi. Pi will go. Okay? then that means k is going to be 2 over 3. So k becomes 2 out of 3. As simple as that. And they said it is a fraction. Then next, state the perimeter of the shaded motif in terms of pi and r. Remember, perimeter is the sum of the lengths around the shape, right? So perimeter of shaded motif. This one is going to be, let's go back and check. So the perimeter, we are seeing this length of this major arc, and then there is also length of this minor arc, whose center is what? C. Now, so this one is going to be length of major arc. That arc is AB with center, its center is O. With center O, then plus length of minor arc AB. Is it? Or I can say AOB. You see that? Minor arc AOB with center C. Okay. Length of an arc, you know that it is r theta in radians. So let's say it's a theta 1 and they all have the same radius. So r, then theta 2. Now, what is theta 1 for the major sector? It has to be this 2k pi, right? So we shall have r times 2k pi, pardon me here, 2k pi, and then we go to this second one here. The angle is this one here, okay, k pi, because this is the arc, and the angle subtended is this k pi down here. Okay, so we shall write k pi r into k pi. Now r is common, not so. So this is 2k pi plus k pi. Don't you get 3k pi? So we have 3k pi r. Now we shall have 3. K is 2 over 3. Not so. So this one will go, and then our answer becomes 2 pi r. As simple as that. Part C, find the area of the shaded motif, giving your answer in terms of pi, r, and root of 3. So if we go back here and we check area of this motif here, we can say area of the big circle, okay, then minus area of this rhombus, not so, then minus area of these segments here, these ones, and these segments are all equal. So if I get area of one segment, then I multiply it by 4, I would have gotten all of these together, okay? So that is that. Okay, so we shall say area of the big circle, shaded area, is equal to area of big circle, then minus, we have area of the rhombus, then plus 4 times area of the other small segments, okay? Small segments whose center is C, okay? Now, we are having the rhombus. Let me try to sketch something here. We are having a rhombus here. Maybe that is the one, okay? And we have this one here is an R, this is an R, this is an R, this is an R, okay? But if you go back and check here, from the center here to this C here, because C lies on this circle, This one is also the radius. Okay, so that means we have r, and r. So that is an equilateral triangle. So meaning these interior angles are all pi over 3. You see that? Pi over 3. So when we go back here, we shall have pi over 3. This is the center, then B, then this is C, and then this is A. So this is also R, meaning this one is going to be pi over 3, pi over 3, pi over 3. Same here. So these two triangles are congruent. They have the same area. So that means if I'm finding the area of this rhombus, then it will be area of one rectangle, then times 2. Okay? Okay. Now we have this one connecting here. Then we have this one here to form the segment. Same here, here, and then here. Now, I will shade these segments here just for clarity. So after these ones here, to get the area of the segment, I will need area of the sector. This is the sector. Then I put off area of the triangle. I'll be in position to get this one. You see that? Now, let's go. Shaded area is therefore going to be equal to pi r squared, area of the big circle, then minus, we open the brackets here. Area of the rhombus is going to be 2 times area of one of the triangles, right? And you remember that a triangle which is not right angled, if you know the angle here and then the two sides that are making that angle, then area is going to be a half times those two sides, then sine of the angle in between. You remember? Okay, so that is what we are going to use also here. This is a half, then times, this is r, then r sine of this angle here. So r times r, then sine of pi over 3. Okay, that is now the area of the rhombus. Let's go to area of the segment. Remember, we have 4 times area of the segment is area of the sector. Okay, area of sector minus area of triangle. Okay, that is how we get area of the segment. So area of the sector is a half r squared, then theta. So the theta is pi over 3. You see that? Then remember, this one is inside here, minus area of the triangle. It is a half, then this and this, then sine of that. Okay, so that is r squared, then sine of pi over 3. Okay, so like that, then we close. Now we shall have pi r squared minus, of course this one will go, then inside here we shall have this one as r squared, then times sine of 60 degrees is root 3 over 2. And then here we shall have a 6 here. Okay, that's 6. Then this one is a 4. In other words, this one goes here 2 times, so that will be 2 over 3. So we shall have 2 over 3 pi, then r squared. And then 4 also in here, we shall have a 2, then times, that is r squared, then times, of course this one is root 3 over 2, root 3 over 2. So meaning this one will cancel with that, then we remain with r cubed, r squared, the square root of 3. So plus the square root of 3, then r squared. Now we are supposed to simplify this one here. By the way, r squared is common. So here I have pi. Then here I'm going to have root 3 over 2. Then here I'm going to have 2 pi over 3. 2 pi over 3. And then here we have root of 3. So minus root of 3. Then r squared. Now, this one here and this one, I can simplify them. So it's like 1 minus 2 over 3. So 3 times 1, that is a 3. Then minus 2, you get a third. So meaning I will have a third of pi. And then for this one here, what are we going to have? By the way, here we are supposed to have a minus, pardon me here, because this one is a positive, then times a negative. So we must get what? A minus. Okay, then, of course, when I open the brackets here, this one will turn out to be the positive. Now we have 1, which is here, because it has root 3, and this one has root 3. So 1 minus a half. Of course, this one gives us a half, right? So that means I will have a half root of 3. So plus a half root of 3, then r squared. This will be my answer in terms of r, pi, and root of 3.